Hello and welcome back to the lecture on applied econometrics. So, we are talking about hypothesis testing. This is the third lecture on hypothesis testing. So, in the past two lectures, we explained what is hypothesis testing. We also spoke in detail about the types of errors that we have to encounter. We also introduced some of the concepts that we need to learn to make a decision for inferencing. We have to make a decision based on the data. So, we need to use some concepts to actually do the decision making. And one such concept is level of significance. Now, before I get into that, let me again recap the concept of type 1 error. So, the type 1 error means, let us say, we gave many examples. So, one example was, let us say, I am not a criminal, not a thief, but jailed, okay? Or I do not have COVID, but diagnosed as positive, right, and then I am treated. So, neither of these situations are desirable, right. Now, both these cases are essentially false positive. We know type 1 error is essentially the false positive cases, false positive, or we can also write type 1 error, right, type 1 error. Now, I claim that the level of significance is nothing but level of significance is a probability of type 1 error, and I will explain type 1 error. All right. So, essentially it is telling us how much tolerance you have for type 1 error. The level of significance is essentially telling us how much tolerance we have for type 1 error. So, if I draw a distribution, let us say I have, let us say it is a one-tail test, and I have the level of significance alpha, and that is basically, that is nothing but the probability is the probability of type 1 error, type 1 error. So, it means the error part. So, basically I will not reject the null, So, this is one of the very important criteria of decision making, not reject the null if my x bar is in this side of the alpha, whereas I will reject the null if my x bar or the sample statistic is actually on the right side of the alpha, the level of significance. Now, why I do that? There is an intuition behind it, and the intuition here is that, well, so these are the errors, Now, how much error I am allowing? Okay. So, essentially try to fill this problem. So, essentially I have my mu here. Okay. So, this is my null hypothesis, that my null hypothesis is that my mu and x bar, they are basically the same, okay, whereas my alternative hypothesis is saying mu is not equal to x bar. Okay. Now, I claim that as long as my x bar is falling anywhere here, it could be here, anywhere, I am allowing so much of space not to change the status quo. So, as long as x bar is in this entire zone, I am saying that I still consider the null hypothesis may not be rejected. Because the evidence that I have gathered, that is still in this zone. Okay. I only reject the null hypothesis if my evidence is so strong that it falls here. If it is here, if it is in this zone, if it is right to the level of significance, okay, only then, only in that particular scenario where my evidence is really very strong that my x bar, my statistic is really far away from my true population parameter, only then I say that we may reject the null hypothesis, or we reject the null hypothesis. Till that point, my x bar, I do not reject the null hypothesis. Okay. So, I really have to have a very strong evidence that my sample statistic is really away from the population parameter. Now, if I look at from the other perspective, let us say I have my x bar here, anywhere here, I do not need to draw it again. So, my x bar here, let me just use a different color, my x bar is here in this point. Now, it can also happen, if you remember when he said that in the previous lecture that like we can have extreme values, right. We can actually see some extreme values of x bar. We can see that they are really far away from the population parameter, but still it might be just be because of an error. It might actually the sample might be actually drawn from the true population, right. Now, considering that, I will say that if the x bar is here and if it is wrongly done, so that is basically the type 1 error. So, essentially that would mean that this is the area that represents the type 1 error. I repeat, it can also happen that the x bar are just the extreme observations, whereas the sample is actually representing the population. Now, when I have extreme observation, the x bar is going to be here, but still x bar is representing mu. Okay. So, this part, that all these points where x bar can actually lie, and yet x bar becomes greater than alpha or the value of x bar is right side of the alpha. So, then we can actually say that it is wrongly done, and when it is wrongly done, so that is nothing but the type 1 error. Okay. So, that is why we call the level of significance is the probability of type 1 error. So, this is basically the concept of level of significance, and this is how we connect the concept of level of significance with hypothesis testing, because we are trying to reduce the probability of type 1 error. So, depending on the value of alpha I take, I decide my tolerance to type 1 error. So, I can have my alpha here, let us say I have a 5, we usually have 5% level of significance, or I can also have 1% level of significance, 1% alpha. So, if I have 1% alpha, so what I will do, I will actually push my bar even further. Okay. So, this is my 1% alpha, this is my 5% alpha. So, that means if I have 1% alpha, I am really not tolerant towards type 1 error, and it depends test to test or context to context, where you want to keep a 5% alpha, where you want to keep a 1% alpha. Sometimes you really want to reduce type 1 error, sometimes you may actually want to reduce type 2 error. Okay. So, we will see that depending on the context we decide this alpha value, and as a thought exercise, the previous 3 examples we have sort of illustrated, you can actually think in which cases you actually need to have very low alpha, or in which cases you can actually allow some tolerances. So, that is one thought exercise that you can do. So, that is basically the concept of level of significance. Now, going forward, we will explain another concept, and that is called confidence level. Now, confidence level, mathematically speaking, is very simple. Confidence level is nothing but 1 minus level of significance. But we need to understand intuitively what is confidence level. So, before I actually explain that mathematically or graphically, let me actually explain it intuitively with a different example. Let us say the professor in your class is, he just wants to have fun in one day in a statistics class, okay, and he asks you that he actually is doing a gamble. Okay. So, it is like he has a reward amount of, let us say, rupees, maybe 1000 rupees, okay, and if you have to participate in that gamble, you have to pay rupees, let us say 100 rupees. Now, the gamble is this. So, in this class, the professor asks you that you have to tell the average height of all the students inside the class. Okay. Now, there are certain categories of the gamble. Okay. It is not just one category. So, there are different options the professor is giving. for you to play. So, one is that I will write it down. One is that you have to tell the exact average height. You have to tell the exact average height. Okay. In other case, he will say, well, I am fine with, let us say 2 centimeter tolerance. Okay. So, if the average height of the class is 5.5 feet 6 inch, 5 feet 6 inch. So, the professor is okay, he will still give you the reward if you can predict, let us say 5 feet 4 inch to 5 feet. If you say any number between in this range 5 feet 4 inch to 5 feet 8 inch, so professor will reward you. Here if you have to say 5 feet 6 inch to get the reward. Okay. If you say 5 feet 5 inch, the professor will not reward you. Okay. And in this case there is some sort of tolerance. Let us say the professor is okay with, let us say 1 feet tolerance, okay, 1 feet tolerance, which means that as long as you are saying anything like 6 feet to 6 feet 6 inch and 4 feet 6 inch, as long as you are saying any number between this range, the professor is going to give you award. Okay. Now, looking at these 3 possible scenarios, it is very commonsensical. Anybody, if I ask you which category of game you want to play, okay, and given that the entry fee remains the same and the reward money remains the same, so I am sure 100% of you will say that I want to play the third game, because you have more tolerance. You have more tolerance to do error, right? You have that tolerance, and yet you are getting the reward money. So essentially, for the third game, you are more confident to play. You are more confident to play the third game, and that is where the concept of confidence level is coming. Okay. So the more you widen your tolerance, the more confidence you have. Okay, and that is what is the confidence level. So if I go back to my previous diagram, here it is my level of significance, and this part is my confidence level. This part is my confidence level. Okay. So essentially, the more I have level of, if I push this line here, so essentially my confidence level is narrowing. So essentially that is how I say this relationship comes from here. Confidence level is 1 minus level of significance, because the area under the curve is always 1. So these two things, level of significance and confidence level, when I add them, they are giving me a number of 1, right. So that is why I have written down that confidence level is nothing but 1 minus level of significance. All right. Now, the example that I have given, now this is a very interesting example, because it is what you understand intuitively is that the moment I allow a wider level of confidence or confidence level, I am actually also allowing more error to be committed, because the moment my range for which I say that the x bar, the sample statistic is actually can represent the population parameter, if I widen it. So that means I am also allowing more room for the error term, right. So this is a trade off we have to remember. This is a trade off is, the trade off is trade off between level of confidence and the error term. Okay. So if I go back to the previous diagram, if I, let me see which one I can show. Let us see this one. If I allow more sort of more room here, if I basically have, it's a bit dirty, let me use a different color. If I allow, let us say I use a red color. If I allow this room here and then this room here, so in this case I am allowing more room. Okay, this one is I am allowing more room, and when I am allowing more room, So, that means I the x bar can be here, and even then I would say that I cannot reject the null hypothesis, but this x bar can actually come erroneously, right. It is, there is the chances are increasing as we sort of move towards the extreme part of the distribution. So, this is why this is something we need to remember, that the confidence interval or confidence level and the error term, there is a trade off. Okay. So, with this we sort of end this lecture. We have talked about level of significance, we have talked about confidence level. We will learn the other concepts in the next lectures. Thank you.